on the air in Cincinnati. Cincinnati, WKRP. Got kind of tired of packing and unpacking.
All right, this is Denver McMurray, Mr. McMurray, and we're here. And if you wonder what happened to me, I'm somewhere else, but you're there. So let's get on with notes. All right, and I'm not at WKRP in Cincinnati. It's just KMUR in Paradise. All right, KMUR, bringing you all the hits all the time and a whole bunch of other stuff that you may or may not want to listen to. Now, the next one we're going to do is going to start talking about connective tissues. We're going to connect all the dots, as it were, and make it all make sense. And your page is going to look something like this after the next page. So it's a pretty full page. You can decide if you want to do it half or turn sideways or up and down, but there's going to be a fair amount of stuff, 4 different columns. So allow for that. All right. Now, for the next one, we're going to talk about connective tissue, which obviously connects things. Some of that we think logically, like bones and cartilage and things like that. But other things we may not think about, blood and fat tissue and some other stuff that are not fat, excuse me, but blood and cartilage and some other stuff that we may not always think about. Okay, some loose connective tissue and dense connective tissue. We'll talk about here in a minute. All right, so they're all considered connective. All right, so one of the characteristics of connective tissue is that you have cells that are embedded in extracellular matrix. In other words, you have living cells, and then they secrete stuff around them that surrounds them and kind of locks them into place. And the stuff around them is some kind of solid stuff. It could be bone tissue, all right, actual bone tissue. It could be cartilage tissue. It could be fibers. And the fibers are technically not alive, okay? For example, here's a bone. After a bone is dead, this stuff is dead. There is no living cells in it anymore. But when you're alive, even in this hardest part right here, there would be little cells that are still alive inside the middle of the hard bone, okay? And they would secrete stuff and things like that. All right, also if you look at a piece of, say, cartilage, okay, there are cells embedded in it, but most of the cartilage is a clear, almost plasticky or hard-looking stuff. And it's not actually alive, okay? That's the matrix, okay? The extracellular matrix is not made out of cells. It's outside the cells. It's secreted, and it can be fibers. It can be hard materials like bone or cartilage. But there are living cells in it that secreted it, all right? Now we're going to put a little scale down here at the bottom. This is from the hardest tissue, and we're going to work our way over the softest tissue, okay? That's just a way of organizing it, and that's how we're doing it, all right? We're going to talk about bones a little bit first. Now, we're not going to talk a lot about bones. Bones are hard tissue. Obviously, we're kind of familiar with bones, even though we don't see our bones very often. But we kind of know how bones work. Now, we're going to talk a lot about bones because we're going to do the whole skeletal system here in a couple chapters, and so we'll get ready for it then. But bones, the main thing you know, the cells are called, because each kind of cell and each kind of tissue has a different name, and these are osteocytes. Osteo means bone, okay? An osteopath is someone who studies diseases or problems with the bone. Osteoporosis is a disease where your bones get porous, particularly as you get older, particularly for females. But generally when people get older in general, my father-in-law, for example, is having a lot of back fractures and stuff because his bones are just getting really thin and soft, okay? And so anyhow, osteo means bone, cyte means cells. So your bone cells, the part that are actually alive with the bone, is called the osteocytes. Now, those bone cells secrete all this hard calcium stuff here. We say bones are made of calcium. Technically, they're made of what we call calcium salts, okay? Now, that doesn't mean that you can salt your food with them or anything. It means it's calcium plus something else, so like calcium sulfate or calcium carbonate or calcium phosphate, okay? So it's those materials, and then they're put into this hard matrix or the bone, okay? There's also collagen fibers, which are like protein fibers that help hold things together, kind of like tendons and ligaments, but they're also part of the bone that actually help hold it together. All right. Now, once the bone is dead, all you see is the matrix is all that's left. The cells are gone. They're dead. They've long since dried up and withered away. Okay, this one still has a few things sticking on the outside of it, but for the most part, that's gone. All right. All right. Now, cartilage, on the other hand, is associated with bones. If you look at this one, I don't know if you can see it there, but on the groove of the bone right there, that's kind of shiny, that's cartilage that was on there, and it dried, and It's kind of shriveled up, so not very thick, but it's very shiny and smooth there. This is a femur or a humerus front leg, and it also is shiny and has a dried cartilage around it. All right, cartilage is important. It's hard, plasticky stuff. It's good for keeping your bones from grinding together. You have your ears, of course, your nose, all that sort of stuff is made of cartilage. So obviously you have different kinds of cartilage. They're not all the same, but you do have cartilage. Now, the cells in cartilage that secrete the cartilage matrix are called chondrocytes. Chondro means cartilage cells, so they're just cartilage cells. That's really all it means. About the only place I've ever seen that word before is chondrioichthyes. Ooh, ichthyes means fish. So chondrioichthyes are a type of fish, and in this case, they have cartilage skeletons, and this would be things like sharks. It would also include things like manta rays and things like that as well. And they don't have bones. You will never see a fossilized skeleton of a shark, okay? You'll see teeth, because they're left over. That's about all you find. Lots and lots of teeth, because sharks have been around for a long time, and a lot of sharks have died and deposited their teeth down into rocks. But there is no bones, so you don't see skeletons, okay? So chondro means cartilage. Now, in this case, the matrix, there's different kinds. It's either cartilage, different types of cartilage that are, some are hard, some are softer, or fibers, okay? And so the matrix in cartilage is either the cartilage or some of it has fibers mixed in with it, which gives it different properties we'll talk about later more specifically. All right, then there are the dense connective tissue. In other words, these are the guys that aren't too bright. They're just kind of dense. No, I'm sorry, not that kind of dense. They are dense because they are closely packed together, okay? Now, when we say they're closely packed together, they're dense connective tissue, okay, what we're really saying is that they are crammed together. There's not any spaces between the fibers, okay? Most of these are going to be fibers, okay? And so the cells that make them are called fibroblasts, all right? They're just having a blast making fibers, all right? So fibro means makes fibers. Blast means to make. Now, blast sounds like you'd be blowing something up, okay? Like a dynamite blast or something. But in this case, blast actually means cells that are making something. In this case, they're making fibers, okay? And so the cells make the fibers. Then there's a matrix of, like I said, the fibers, and that's the matrix. It's just the different fibers they make. All right. Now, there are two types. There are regular dense connective tissue, and there is irregular, and we'll look at that in a second. But regular means that they all run parallel to each other. I would draw lines on here, but the last time I did that, it wouldn't let me click on some stuff that I want to later. So, we're going to say that it, well, I'm just going to go do it anyhow, because that's just how I am. All right, I'm just going to go and do it, and there we go. So regular means that they are all parallel to each other. Now, they're tightly packed together, and I can't draw them that way, but you get the idea. They're all on top of each other and stuff, but they're all lined up parallel, okay? Now, this is things like tendons and ligaments. Tendons attach your muscles to the bone. Ligaments, like you have a bunch of them in your kneecap because it connects bone to bone. So your kneecap has to be attached to all the different bones, your femur in the top and the tibia and the fibula down at the bottom. So there's a lot of ligaments, ACL, AML, and whatever. There's all the different ones that can be torn, okay? Now, because these run in a line like this, I lost my cursor, but okay. I don't know where it went. Oh, there it is. It's on the other screen. Okay. All right. Cursor. Because they run a line like this, they're very strong if you pull on them. If you pull straight line on them, they're very strong. And your tendons and ligaments will stay pretty much where they belong. But if they get twisted and you tear them from side to side, if you pull on them this way, all right, or this way, a lot of times these fibers, although they're strong this direction and won't snap, although occasionally athletes do snap them, but if we twist them and pull them this way, they will pull apart or shred a little bit in the middle, okay? And so a lot of times people tear, or which may actually tear it where it attaches to a bone, or it may tear somewhere in the middle of it. And so you can damage those tendons and ligaments, all right? Now, because these ligaments and tendons have very poor blood supply. They just have a few blood cells in there, a few cells in there, and they secrete these fibers. They don't get much blood to them. If you ever looked at tendons, they're white. Why? Because they don't have any red tissue in them, no blood. Okay? And since they have poor blood supply, they do not heal very well. And so it's very often someone tears a tendon or ACL or whatever, and then they go back to playing sports too soon. They say, well, it doesn't hurt anymore. But it hasn't really healed because it takes such a long time for that to happen, and you're paying them millions of dollars, and you're losing football games or basketball games or baseball or whatever. And so it's like, we got to get them in there. And they get in there and they tear it again and rip it up. Okay, so they take a long time to heal because of that poor blood supply. Some people sometimes they say it's better to break a bone than to tear a ligament because once the bone heals, it's healed. All right, not so much with the ligament and tendons. All right, now the other is irregular tissue. All right, that means it can't go to the restroom when it needs to. It gets constipated. No, that's a different kind of irregular. Sorry, irregular means that they go in all directions. Okay, they don't line up parallel. Some of them go this way, some of them go that way, and they're just here. But they are dense still, so there's going to be a thick mat of these laying on top of each other. In fact, so much so it's solid after a while. Okay, so they go in all directions. Now, the nice part of that, they don't run in one direction. There's that rock group again, one direction. Okay, like these do. These listen to one direction all the time. That's the only way they go, is one direction. And they're very strong one direction, but not so much the other way. The irregular goes in all directions. So no matter which way you pull on it, you're pulling against some of those fibers. And so it's not going to split open. And this is a good thing because this is your dermis or your skin. You don't want to pull sideways in your skin and just splits right down the middle, which would happen on a tendon. Okay, you want your dermis to be strong. No matter which way you pull apart on it, it does not split apart. Okay, that's very important for your dermis. All right. Now, the next one is loose connective, and notice how I managed to write that right in the wrong spot there. Wasn't that good? All right, it took me a long time to do that. All right, loose connective. So it's also going to be connective tissue. It's also going to be fibers, but these are going to be with a lot of space in between them. You're going to have more cells and less fibers. So it's almost like a framework. You have all these fibers, and then the cells are kind of hooked on those. Okay, so let's look at some examples of that. The cells would still be called fibroblasts because they're still making fibers, just like we did over here. You got fibroblasts, so the cells are there. You still have a matrix of fibers, but these tend to be softer because you have more cells, less fibers. All right, and so they tend to be soft, and they're not very packed very tightly. So these are kind of squishy tissue. There are some things, not like after you sneeze your nose and all, that's a different kind of squishy tissue. But these are things like your spleen and stuff. And they're kind of squishy organs that are not real hard, real firm, but they are still, a solid organ, but they're a little on the squishy side. All right? All right, and those are the loose connective tissues. All right, now we're going to talk about some of these in more detail. Bones we're not going to talk about, like I said, because we will hit that in its own special chapter in the skeletal system. All right, but we will let's talk about cartilage first. All right, and it's going to take about this kind. There's 3 kinds of cartilage. It's not going to take up a lot of space. You could probably squeeze this into a half a thing if you had to. All right. All right. Now we probably won't get through all this before I run out of time. So if I need to, we will just stop it and go to the next video. How exciting! 2 videos in one day. You'll be so excited. All right, cartilage. So cartilage is going to have, it's avascular, okay? Kind of like the dense connective tissue that just has a little bit of blood vessels. Cartilage has absolutely 0 blood vessels. Vascular means vessels, A means none, and so they are avascular, or they have no blood vessels. All right. Therefore, if you tear your meniscus, which is cartilage on the knee, or you tear any cartilage in knee, hip, wherever, it is not going to heal itself. There's no blood supply there, and so there's not going to be any blood coming in to heal it, and you're just kind of out of luck. Okay. So it's not going to heal up. It's not going to get better. Okay. They may, if a part of it sticks out and hurts when you bend your knee or whatever, they can shave that off and stuff like that, but they can't really replace it. Okay, or do anything with it. Okay, you're pretty well sunk. All right, and as we said, the cells are called chondrocytes, and they make a matrix of the different kinds of cartilage. And the rest of it will have to wait till the next video.